the GIF entrance aperture. So if we are in F10 mode and we want to access the spectroscopy apertures, you just right click on the F10 kind of button in the microscope UI, go to the bottom menu item, which is aperture, and then we can choose our two apertures. So I'll start off with the high SNR. So our high SNR aperture looks like he's about there. So we do exactly the same thing. Let's stop the view. And I'm just going to use my ROI tool. So I'm looking at these little markers that are on the line profile, and I'm just using it as a kind of approximate placeholder. So then, okay, so then my diameter there is about 40-ish. So we're going to say 5 millimeter GIF EA 5 millimeter equals 38.361 divided by 2. GIF EA 1 millimeter is let's do the same thing again. There we go. Last one. Eight. So way smaller. 8.384 divided by 2. Now, I'm just going to go back to the 5 millimeter aperture. There we go. So one more important point. So when we're in diffraction mode, so when we're defining our collection angle with the GIF entrance aperture, the measurement's going to be camera length specific. So look, the projected size of the GIF aperture is going to stay fixed with respect to the diffraction pattern. So if I increase the camera length, you see how our scale bar is changing, our spot separation changes, but the aperture, it remains constant. So if we're making measurements in diffraction mode kind of eels, we need to make those measurements for the different camera lengths. Now for imaging, when we are using the objective aperture to limit the collection angle, that's not the case, because the projected size of the objective aperture will kind of change as the diffraction pattern changes. So you can just do that at one camera length and you're good. Okay, so that's how we measure the angle, the collection angle. So now let's acquire some electron energy loss spectra and see what the actual effect is on our EELS data.